So here I'm going to talk about units 1 through 3 and the different types of graphs we did then so that you can have a review of what we looked at. This first function here is going to be an absolute value function. So what that tells me is that I expect it to be a V-shaped, whether that's right side up or upside down, whatever it may be. But that's the shape I expect out of my graphs when I get done. If it's not, I know something's wrong. And really what I'm going to do here is remind you what we talked about when we graphed these way back when and how we got the values for your t-charts and all of the information. So the first thing we did is we identified our vertex when we did these. Your vertex here, it went right 2 and up 6. So my vertex would be at 2, 6. And so I'm going to go to 2, 6 and plot that on my graph. Then we talked about getting your points two different ways. One thing we said is you are welcome to make a t-chart. Put your vertex in the middle, since we know that's going to be this point in my graph in the middle, and then plug in points to the left and the right, so 1 and 0 or 3 and 4. And you're absolutely allowed to plug those in. They should mirror each other, so 1 and 3 should have the same value, 0 and 4 should have the same value. If you're plugging that in, make sure you start here. So if I do 0 minus 2 is negative 2, but the absolute value of negative 2 is 2. So I'm really doing 2 times negative 3, which is negative 6, plus 6 gives me 0, and I can fill it down here as well. If I plug in, say, 3 minus 2 is 1, absolute value of 1 is 1, times negative 3, plus 6 gives me 3. Be careful, because if your calculator doesn't have an absolute value button, you might not be able to type this in directly, so you will have to think it through. However, that's not the only way we talked about it. What we talked about also is that this number in front will be your slope. The negative tells me it opens down, and the 3 tells me how steep I need to go, so I need to go down 3 and over 1. What that does for you is you can really just count your points also if you'd prefer. And if you notice, the points we got by plugging it in are the same as what I get if I actually count that slope, so either way is fine. Then if I go through this t-chart, or the characteristic chart, sorry, my domain, as we said in the last video, is always negative infinity to infinity on absolute value. Range is bottom to top, so it goes from negative infinity all the way up to 6. I don't have any vertical asymptotes or holes here. For my limits, on both the left and the right, my function is going down. And so that'll be f of x equals negative infinity for both of them. I do have a maximum value here. The ordered pair is 2, 6, and I don't have a minimum. It is increasing from negative infinity all the way up to that y, or that x value, sorry, to 2. And it is decreasing from 2 to positive infinity. Our x-intercepts I can see here, and so I'm just going to use those. My x-intercepts are at 0, 0, and 4, 0. My y-intercept I can also see it's at 0, 0. This function is from our square root. This is from unit 2. If you're looking back in your notes, this is a square root function. What we said here, and if you think back to our examples, we cannot plug in anything we want because this square root, we can't have negatives under that square root because we won't be able to plug that in. So what we did at first is we figured out what would make under my radical equal 0. There we go. That's what I wanted. Well, you can get that. It's always just going to be your h value. And so it's going to be that 3 if you switch that sign. Or you set x minus 3 equal to 0 and solve that equation. And then what we also did to make this easier is we wanted to force under the radical to be perfect squares. So we want to force x minus 3, oopsies, to be equal to 1, or equal to 4, or equal to 9, because that's going to give me pretty numbers when I plug it in. If I solve x minus 3 equals 1, I get 4, so I'm going to plug in 4. If I solve this x minus 3 equals 4, I get 7. And if I solve x minus 3 equals 9, I get 12. When we did these, we used our perfect squares for graphing our square root functions, and you'll find we do our perfect cubes over here for graphing our cube root functions. But now I'm just going to go ahead and evaluate these. When I plug in 0, or plug in 3, sorry, it makes my whole radical be 0. So square root of 0 is 0, times 2 is still 0, so this is at -5, because you just do 0 minus 5. Plugging in 4 makes under the radical 1, so square root of 1 is just 1. So it's 2 times 1 minus 5 is -3. If I plug in 7, 7 minus 3 is 4. Now be careful here because a lot of people forget to square root it. Square root of 4 is 2. So it's 2 times 2 is 4, minus 5 is -1. If I plug in 12, 12 minus 3 is 9. Square root of 9 is 3, times 2 is 6, minus 5 gives me +1. So at 3, I am down here at -5, and then at 4 is -3, 7 is -1, and I know way out here at 12, we'll call it, I'm at 9. So here, to the best of my ability, is that curve. And now we'll talk through this chart. So your domain, we couldn't plug in anything left of this, so it is from 3 to infinity. Your range is bottom to top. The lowest this graph goes is -5, and then it goes up to infinity. No asymptotes or holes here. The left-hand side of my graph is approaching that point. It's approaching -5 for a y value. The right-hand side of my graph is approaching positive infinity. It's going to keep going up. I don't have a maximum because it goes up forever, but I do have a minimum here at 3, -5, that starting point. This entire function is increasing because it's going up to the right. For my x-intercepts here, we're actually going to have to do some work. We know it crosses somewhere between 7 and 12 because that's when I go from -1 to +1, but I'm going to have to actually solve it. And this is why we had our 7a activities. Because if you remember, to find an x-intercept, you have to set your equation equal to 0 and solve. So when I'm doing this, I'm going to add 5 and divide by 2, which gives me 2.5, or you can leave it as 5 over 2. Getting my calculator, you're going to have to square both sides to isolate or to cancel out that radical. So 2.5 times 2.5, or 2.5 squared, is 6.25 equals x minus 3. And when you solve that, you get that your x-intercept would be 9.25. For your y-intercept, I would always recommend you just look at the graph. This is never going to cross, and so it's going to be none. If it did cross and you weren't sure, remember that's when we plug 0 into the function and actually evaluate it. And the reason it doesn't work here is you would do the square root of -3, which doesn't work. You would have an I in it, and so we just move on. Here is going to be very similar, but it's going to be a cube root function. It starts out, though, almost exactly as our square root function did. But what we talked about, we do not have a starting point here, we have a turning point, because your cube roots, if you think back, go both ways, forever to the left and forever to the right. And so we find our turning point, which is always at your HK, so your 4, 1, and we put that in the middle. And that's what makes under my radical equals 0. So we did also talk in class that you can just do under your radical equals 0 and it'll get you that. And now, last time we said we put our perfect squares off to the side. Here we're going to put our perfect cubes off to the side, both positive and negative. And what you're doing is you're doing x minus 4 equals each of those numbers above. So if I do x minus 4 equals 8, I get 12. If I do x minus 4 equals 1, I get 5. If I do x minus 4 equals -1, I get 3. And x minus 4 equals -8, I get -4. And then we're going to go ahead and plug all these in. Again, you can use your calculator, you can do it in your head, however you need to. When I plug in -4, under my radical is -8. Cube root of -8 is -2. Plus 1 is -1. Plugging in 3 under the radical, I get -1. Cube root of -1 is -1. Plus 1 gives me 0. Plugging in 5, 5 minus 4 is 1. Cube root of 1 is still 1. Plus 1 is 2. And then 12 minus 4 is 8. Cube root of 8 is 2, plus 1 gives me 3. So I'm going to go ahead and plot all of these so that I can graph it. Again, one goes off. You can just kind of approximate it off to the side so that your graph will approach whatever it is. Okay. For my domain, it's going to be negative infinity to infinity, like all cube root functions. Your range is bottom to top. While this is going slowly, it will continue to drop and rise because there are no asymptotes, so it is negative infinity to infinity. And we'll cross off all those asymptotes and holes. On the far left, my graph is going down, so it's going to be negative infinity. On the far right, my graph is going up, so it's going to be positive infinity. Here I do not have a max or a min because it doesn't dramatically turn around and go the other direction. I am only increasing, so I'm going to write my whole domain there, none on decreasing. For x-intercept, I got lucky, and it was with a point that we had right here, so I don't have to solve it like I did last time, but you would just do the same we did last time. However, for y-intercepts, I didn't get lucky. I do have one, but I'm going to have to plug it in. So that means I'm going to add a number to my chart. I'm just going to plug in 0. This will typically require a calculator if it didn't already show up because you can't do that radical in your head typically. I'm going to have to grab a different calculator. My phone can't do cube roots. If I do the cube root of negative 4 and then plus 1, I get negative 0.587. And so that's my y-intercept. And the thing I always check, remember, make sure these make sense. That looks like it could definitely be negative about 0.5, so I'm sure my math is about right. Last thing we're going to talk about is quadratics, and I gave them to you in 2 different forms back when we learned this in both Unit 1 and Unit 3, so I'm going to talk about the same ones here, but these equations will get you actually the same graph on purpose so that we're not doing 2 extra problems. I'm not sure why that got bigger, I apologize. So our 2 forms, remember, is your vertex form, which is what this first one is, and your second form is your standard form. And graphing these both is exactly the same, but with one slight caveat. When you graph it, you know this is a quadratic, and so you know it will be a parabola. And so since it's a parabola, I want to find this turning point to put in the middle of my graph. And depending upon the way I give you the equation, you have to do it differently. If I give it to you in vertex form, you are just picking out your h and your k directly. So for example, with this one, it would be negative 2 and negative 3. Remember, your h, you always flip that sign. However, if I give it to you instead in standard form, you need your formula for your vertex, which is negative b over 2a. Just to show you that this does work out and give you the same thing, my b value here is the 4. So my vertex would be at negative 4 over 2 times 1, which gives me negative 2, which is what I already had. To get your y value, or this negative 3, you would just have to plug the negative 2 into your function and actually evaluate it, but it does give you negative 3. Once you do that, there is absolutely no difference between graphing from vertex form or standard form. When you get to this point, you're then going to plug in values around your vertex because, again, we want to find these 2 sides. So I'm going to plug in like negative 1 and 0, negative 3 and negative 4. And what we talked about in class is that you will have this axis of symmetry. So negative 4 and 0 will have the same value, so will negative 3 and negative 1, just like your absolute value functions. What I'll do to show you is plug 1 into each of these equations to show you how you would do it. If I'm plugging into equation into vertex form, you just plug in the 1 time. So I will do negative 4 plus 2 is negative 2. Squared is 4. And then minus 3 gives me 1. If I wanted to do the same thing by plugging in negative 4 here, you would just plug it in both spots. So I would do 4 squared, negative 4 squared is positive 16, plus 4 times negative 4 is negative 16. So this is really 16 minus 16 plus 1, which also gives me 1. But I'm going to go ahead and plug in the rest of the values. Really, I just need to plug in negative 3 or negative 1. If I do negative 1 plus 2 is 1. Squared is still 1. Minus 3 is negative 2. So at negative 2, I'm down at negative 3. At negative 1, at negative 2. And at negative 4, I'm at 1, and same with at 0. And now let's talk through this chart. For your domain, we can plug in whatever x value you want to any polynomial. So that's going to always be negative infinity to infinity. Your range is bottom to top, so the lowest this goes is negative 3, but it will go up to infinity. Today, again, we don't have any holes or asymptotes. The left-hand side of my graph is going up forever, and so is the right-hand side. I do not have a maximum, but I do have a minimum at that vertex of negative 2, negative 3. My graph both increases and decreases. And so if I think about it, on this left-hand side, so from negative infinity all the way up to negative 2, I am decreasing. And then from negative 2 to positive infinity, the right-hand side of my graph, I am increasing. I'm going to do the easy one first here. My y-intercept I found already because I already plugged in 0, so it's at 0, 1. For your x-intercept, you're going to have to do a little bit of work that we're going to talk through together. So for this x-intercept, you're going to have to solve your equation, and you can do it from either form. It is typically trickier to do it this way, and that is also what we more primarily focus on in Algebra 2, so I'm going to do it from here, but know that you can do it from here as well, and I'm happy to help you with that. I'm going to write this on the next equation, or the next screen, so that I have some space. And what you're doing, again, is you need to find your x-intercept, so we're going to set it equal to 0. And if you remember from our 7a unit or from our 3a unit, this is where we're just going to have to try to factor. And if we can't factor, we're going to quadratic formula. This one, you can't multiply to 1 and add to 4, so we can't factor, which means I'm going to have to quadratic formula, which is part of why I wanted to do this one from this equation. And so I'll plug it in. You got your negative b plus or minus your b squared minus 4ac all over 2a. Which gives me negative 4 plus or minus, this is really just 16 minus 4, so 12 all over 2. And then I'm really just going to type this in your calculator because here I want that actual decimal value. When you're doing this, type in the top first. So I'm going to do negative 4 plus the square root of 12, which gives me negative 0.538. And then I'm going to divide that by 2. So I'm going to get negative 0.268, we'll call it. And then I'm going to do negative 4 minus the square root of 12 because you have to do both. Get about negative 7.46. I have to cut it in half because of the denominator. So I get negative 3.732. So these would be my two x-intercepts. Whoopsies. For this graph, the negative 3.7, call it, and 0, and let me cheat off myself real quick, negative 2.27. Okay, and again, always check your graph and make sure those seem reasonable. Again, if you want to solve it from this, you can. What I would do is add the 3 and then square root both sides, remembering to get a plus or minus, and then just minus the 2. Both are pretty straightforward ways to solve this.